Hi, I am Varat Joshi. I am a PhD student at the University of South Carolina. I am advised by Professor Yanis Dakliatis at the Autonomous Field Robotics Lab. Today, I'll be presenting our paper on robust underwater state estimation by switching between model-based and visual-inertial odometry. VIO failures occur in challenging underwater environments due to limited visibility, low dynamic range, and color loss. One such scenario occurs when Aqua-2 autonomous underwater vehicle is navigating over a shipwreck and it reaches the side of the shipwreck. As a result, the AV faces open water and cameras capture images with only blue water. The VIO system cannot detect enough features in these images and diverges eventually. During field experiments, robots are required to maintain a reasonable pose estimate. To handle scenarios of VIO failure, we propose to use a model-based estimator dependent only on interoceptive sensors. We track the health of the VIO based on various criteria, and whenever VIO health degrades, we switch to the model-based estimator. We keep monitoring the VIO health and switch back to VIO when the health indicator shows recovery. Thus, we combine the pose estimates from both estimator, switching back and forth in a loosely coupled fashion, depending on health status, into a pose graph. Whenever the AUV encounters a loop, the pose graph is optimized to obtain globally consistent trajectories after loop closure. We employ a model-based estimator named primitive estimator by combining IMU filter, depth sensor, and motion commands. Whenever VIO is working, it is the preferred estimator. The pose estimate from either the primitive estimator or VIO is added to the pose graph based on health tracking status. If the VIO health is good, we use the estimate from VIO to robust trajectory. Whenever VIO health degrades, we use the estimate from a primitive estimator. In this way, the robust trajectory locally tracks either the VIO or the primitive estimator. We employ hierarchical criteria based on the number of 3D key points tracked in the keyframe, the number of features tracked per quadrant of the image, the ratio of newly detected key points to existing feature tracks, and the average corner response of the feature detector. The value of these parameters are chosen empirically based on the VIO method employed. We tested the robust estimator in three different underwater environments. We will focus on the first two for this presentation. In the first dataset, Aqua-2 AUV is performing a lawnmower pattern over the Stepnorikita shipwreck, Barbados. While performing the desired motion, the AUV moves outside the side of the shipwreck multiple times. In the second dataset, the Aqua-2 AUV is performing a square over coral reefs in Barbados. A large section of the squared pattern is performed over a sandy patch. Initially, the VIO and primitive estimator are working well. Whenever the AUV reaches the side of the shipwreck, the feature detection fails and switching to primitive estimator occurs. When the AUV moves closer to shipwreck again, the feature tracking recovers, thus switching to VIO. Whenever a loop is detected, the whole trajectory is optimized. We compare the performance of our method with CallMap used as ground truth. CallMap only registers images over the shipwreck, and partial trajectory is used for quantitative evaluation after SE3 alignment. Compared to VIO-only algorithm, our method performed better. More importantly, it is able to track the AUV throughout the whole experiment. In this dataset, the VIO diverges when Aqua 2 moves over the sand and the robust estimator switches to primitive estimator. When the AUV sees the corals again, it switches back to VIO. The whole trajectory is optimized after loop closure. It should be noted that only VIO keyframes are used for loop closure. The images show final trajectories of the VIO, primitive estimator, and a combination of both. The green diamonds show where the switching took place. Thank you so much for being part of this presentation. Please visit our poster as well. Thank you.